Hey everyone, welcome back to Daily Standup. For this one, I kind of just want to give a demonstration of how I'm using SignalR to make WebSocket requests with data going to my backend, and then from the backend to the client or the front end. So if you see on the left here, this is like what's sending the data from what's the current, what currently is the engine simulator. So I have it making requests every about 20 requests a minute, which this is specified here. And then I specify to use SignalR, and then I'm just start requests. And I wired up all this to basically allow me to toggle between using REST APIs and using WebSockets. So I'm currently using SignalR. It's making active requests to the backend. So how this is working is that if we look at the front end code, let me scroll some windows out of the way. This is going to get to be chaos. So this is the front end code. It's React. So if I go to engine, and basically I need to go to my Q hub here, right here. So this is the hub that is the data is being sent to via SignalR. So I have it in a use effect hook, and it's going to be called once upon creation of this component. So then if we go down to, hold on, let me actually start request, if use API, else use SignalR. So this is going to call this SignalR connector method, which if we go here is this async function right here, and it's basically going to build this basically a mock engine data variable, and then it's going to invoke this method. And that's really what I want to show you is, since we have the connection, that's what I showed you is being built on the component entry, we can invoke a method on the back end if we provide a, you'll see here, the method name as well as any of the arguments that we want to send up to it. In my case, I want to send this engine data up to this send message method. So now that we have that, if we go on to the back end here, let me make this a little bigger. So if we go onto the back end, you can see that in my program CS file in the middleware, we have mapped hub for Q hub, and with the route Q hub here. And if we go back to our SignalR connector here, we can see that we are providing the connection to be the port number and then the Q hub, which is the route, right? So that's what we've mapped here for when we set up SignalR. So if I go over to this type here, so Q hub, and I have it in this file here for SignalR hubs, Q hub, you can see that it's of type hub, and all we have to do is basically create that that send message method. And if we go back to the front end, again, we saw, let me make this text a little bigger. If we go down here, we're invoking the send message method. So that's being invoked here, and then we publish it up to my RabbitMQ server, the queue. So I have it wired up to be on the message bus with mass transit. So that's ultimately how it's getting to RabbitMQ, and then being read by the Rust microservice here. You can see it reading a bunch of all the engine temperature data. So that's kind of the flow of SignalR from the front end to the back end. Now I want to show you the flow of SignalR moving from the back end to the front end. It's roughly the same. It's largely the same process, but what I have done is, if we go back to the startup pipeline, you can see that I have wired up notifications hub. Okay, so to back up a little bit, the way I'm getting messages from my RabbitMQ down to my front end via SignalR is you can actually inject a custom hub context and then provide it your registered hub that you're using for SignalR. So I showed you this hub, notifications hub, and I'm actually technically, I guess, not using this send message method. Now I have it here just in the event that I choose to do so, but I need this stubbed out because I have to provide a type for this iHub context. So we have to inject that with dependency injection. And then what we can do is, now that we have that hub registered, and again, if we go to our startup, we have that our hub is given this route, and that's what the front end needs. So if we go back to our notifications consumer, which is responsible for reading messages off my my RabbitMQ server with a mass transit, we can see that I have the message sending down here. So if we go here, again, it's sending, we give it a method name, notification received, and we're giving it the argument, so result. So the result in this context is the message off of our queue. So that's being broadcasted to everything that's registered to listen to that notification hub is being broadcasted to all that. So if we go down to, again, the front end, and if we go down to my notifications component, you can see that I have a connection to that notifications hub in this method, and then I have connection on notification received. That means I'm saying, okay, when we receive a message on this with this name, then we're gonna execute whatever this is. In my case, I'm just setting a notification display on the front end. So hopefully that makes sense. A lot of this is subject to change. This is just me prototyping some things. But this is how I set it up to read a message off of RabbitMQ and then send it down to my front end via SignalR. So that it works pretty well. I don't know if I'm sending enough messages right now for it to show. I can bump that number up to show you how this works. So I'm gonna start sending, let's just say 2,000 requests a minute. Not a whole lot, but we'll start that, and we'll start requests. So now we're sending a lot of requests. We should see notifications come down right there. There's one. So so it overheated, and then overheating, and then engine overheated. So those all are provided with SignalR in real time, and we're not experiencing any lag to the front end. So again, we're sending messages from this engine with SignalR up to the back end, as well as receiving messages. So if we bump this up to 20,000 and we start requests, now we're sending roughly 20,000 requests a minute, give or take a little bit, and they're all being consumed by my Rust microservice here. You can see this number going crazy. So it's keeping up with it, and we're not experiencing any sort of lag on the front end. We can type whatever we need to, and we're just fine. So it works pretty well. That's just how I have it set up how I'm using SignalR, and I'm going to just kill that connection. I don't want to send that many messages. If we go back to Rust, you can see that it keeps up with it, and we're not actually receiving any more messages because it kept up with it. So you can see that in real time, the system works pretty well, and we're just leveraging existing technologies. That's technology that's pretty much built into .NET with SignalR. So that's how I have it set up. Hopefully that makes sense a little bit. If you have experience working with SignalR and .NET, there's a couple ways to establish that connection to the front end with SignalR, and then vice versa. This is just one particular way that I did it, being able to inject a custom notification hub and call it outside of the traditional hub context. And I have it injected into my consumer class that is registered to listen to my RabbitMQ server. So hopefully that makes sense. A lot of it comes down, honestly, to configuration on the startup pipeline. So if you go up to my mass transit registration here, you can see that I have a couple consumers. The notifications consumer is one of them. and that's going to be wired to listen to specific endpoints. So we have a couple receive endpoints, logging. We have a receive endpoint for notifications. That's the one that's being called. And we're specifying it specifically to use our notifications consumer. And we have it specified to use raw, be able to read raw JSON. So honestly, a lot of it, if you're wiring this up and you run into problems, a lot of it is going to come down to what you're doing on the startup pipeline. So you just have to make sure that is set up correctly. It took me a while to set this up and configure it right, but honestly, now that it's set up and working, I shouldn't have to go back and change as much. And Mass Transit makes it really easy, because if I wanted to add another consumer to this, all I have to do is basically just add another consumer file, register it here, and then tell it which and then manually wire up which queue in my RabbitMQ server, which consumer is going to be responsible for listening to that queue. And then you can provide custom serialization and deserialization as you need. So honestly, that's tough to beat. It works really, really well. And then if you come down here to add SignalR, you just add it to the pipeline. And then you can, it's just, .NET makes it super easy. Well, not easy, but it's super nice to wire up like really, really advanced stuff that you would use in like a production setting. But yeah, so that's how I have it kind of working in the system. I plan to add a lot more to it. Hopefully that makes sense. And yeah, I can show more in depth anything of this system as I kind of build out the architecture of this. There's one thing else I wanted to try, as opposed to, because you saw that I just had I'm using SignalR or using REST APIs. So I built this toggle just to experiment with a couple things. I like to add a button to try to establish a connection right to RabbitMQ, but there's some stuff that I have to do, just given that I'm not hosting. This is a single page application, but it's being hosted on my, in my .NET web app. So I think I'd have to do some weird stuff with getting a node server running to be able to establish connection to that RabbitMQ server. I think I could be wrong about that, but I don't know. But yeah, so that's kind of it. Yeah, so that's just kind of showing one way to get near real time notifications on your front end without interrupting anything or creating this like synchronous connection between a couple microservices. Everything is asynchronous. Nothing waits on anything else. So I think it works pretty well. Yeah, but that's it for me. So I'll see you guys on the next one.